One thing that is important to understand is exactly how easy it is to go between having fractional coefficients to having some algebraic expression where it looks like you've got a term on top and then a constant on the bottom. Really, these two things are the same thing. That's the main thing I want you to take away from this, that these are the same thing. For example, 3 over 2x, where I've got a coefficient of 3 over 2 in front of my x, is exactly the same as 3x over 2. And that may be obvious to you, may not. What's important is just that you be able to go back and forth between the two of these without even really thinking about it. So let me show you why this is true first. Let's say you've got 3 over 2x, and you know that 3 over 2x, when I've got a number in front of the x, that's just the same as saying the number in front times x, right? 3 over 2 times x. So far this is making sense. And we also know that x, whenever I've got something like this, anything, I can always just put that over 1. So 3 over 2 times x, the same thing as 3 over 2 times x over 1. Now, if I think of my rules for multiplying fractions, I know it's always top times top and bottom times bottom. So if I just take 3 over 2 times x over 1, I multiply top times top, which gives me 3 times x, and bottom times bottom, which gives me 2 times 1. Now, 3 times x is 3x, and 2 times 1 is 2. So I started out with 3 over 2x, and I ended up with 3x over 2. 3 over 2x is exactly the same as 3x over 2. You can just bump the x up on top of the numerator, and you haven't broken any rules. You still got the same thing. What is the coefficient of 5x over 8? Well, if we take what we just saw and move it backwards, you can see why the coefficient of 5x over 8 is what it is. The first time you see something like this, you probably had the reflex of thinking, well, I think the coefficient here would be 5 because that's the number in front of the x, right? But it's not 5. And here, let's figure out why. It's going to be 5 over 8 if you think to yourself, I've got 5x over 8, which is the same as 5 times x over 8. That's what 5x means, 5 times x over 8. And that's just the same thing as 5 times x over 8 times 1, right? All I've done here is I've taken this 8 and turned it into an 8 times 1, which is the same thing as 8, right? I haven't changed anything here. But I also know that 5 times x over 8 times 1 is exactly what I'd get if I were trying to multiply the fraction 5 over 8 times x over 1. Let me show you what I mean. If I had 5 over 8 times x over 1, I'd multiply top times top to get 5 times x, and bottom times bottom to get 8 times 1. And so far what we've gotten is that 5x over 8 is equal to 5 over 8 times x over 1. But 5 over 8 times x over 1 is just the same thing as 5 over 8 times x. All I've changed here is instead of writing x over 1, I've changed it to x. And I could do that because the over 1 here, that's just kind of like the formal last name of anything. You can always add on over 1 to it. So I can just take that over 1 away, and I've got 5 over 8 times x. I can also think of it as x over 1 is the same thing as x divided by 1, and x divided by 1 is just x. So we've gone from 5x over 8 to 5 over 8 times x. But when you have this 5 over 8 times x, remember that's just the same as writing 5 over 8x. Whenever you've got that times there in algebra, it's already implicit. You don't even need to write it, right? It's just the times is already there. But what I've got here now, it's maybe a lot clearer to see that I've got an algebraic term whose coefficient, that is the number that's in front of the x, is this fraction 5 over 8. And that's my coefficient. So 5x over 8 is exactly the same as 5 over 8x, which means that in both cases, the coefficient has got to be the same. It's got to be 5 over 8. Now, where would that actually be useful? Well, let's say I'm dealing with an example like this one. I've got 3 over 4 times t, and I want to know for sure that that's the same thing as 3/4 t. That's the same thing as 3t over 4. If I can move between all these three, then it opens up possibilities for cross multiplication. It means that if I have a case like this, then I might want to write it like this so that it makes it easy to cross multiply. Because cross multiplication only works if everything on either side of the equal sign is either on the top or the bottom of a fraction. And this doesn't quite look like that, so if I rewrite it like that, I can see this is the top, this is the bottom of a fraction, and on this side of this equal sign, that's all I've got. Likewise, if I've got something like 5 over 7 times r, I can rewrite that as 5 over 7r. I can rewrite that as 5r over 7, right? I can also say to myself 6c over 11 is the same thing as 6 over 11c, or 6 over 11 times c. Now, if I'm in a situation where I don't want to cross multiply, because it's not an equation where cross multiplication would be useful, but I do want to know exactly what the coefficient of c is here, then this is a handy way to think of it. Let's say you've got this equation, 3f over 8 equals 27. Now there is a way you could deal with this through cross multiplication, but for now I just want to think to myself, okay, I want to isolate f. And the way you isolate a variable in a case like this is you just divide it by its coefficient. So it helps to know what the coefficient is here. Remember, 3f over 8 is the same thing as 3 over 8 times f. We just saw that before. And if I know that the coefficient here is 3 over 8, because it's the same as 3 over 8 times f, then if I divide this side by 3 over 8, I'll just be left with f. You can do this yourself. If you flip this over, this becomes times 8 over 3, cross cancel, you end up with 1f over 1, which just becomes f, right? That's why you divide by the coefficient, to get all those things to cancel out. So over here I'm left with just f, and over here I just have to do this division over here. I've got 27 divided by 3 over 8, which I can think of as 27 times 8 over 3 if I just get the reciprocal here. I'm going to put this 27 over 1 just so that it makes it easier to see that it's a fraction. Now I'm going to do a little cross canceling. I can divide this 27 by 3 and this 3 by 3, which leaves me with 9 up here and 1 down there. And then I do 9 times 8 on the top to get 72, and 1 times 1 on the bottom just leaves me 1, so I end up finding out that f is 72.